Hello, everybody. Welcome back to the series where I try and learn systems programming, and trying to learn it through this new and fun language called Zig. Um, Zig is a general purpose programming language, but from what I've read about it and heard about it, the, it's all claim is to be a systems programming language that is very precise in its syntax, and something that I've always wanted to learn is programs is writing programs where I have a deeper understanding of the hardware. Um, Professionally, I've been writing C Sharp, ASP.NET Core, Angular, and TypeScript, so a lot of the web technologies. And you can build beautiful services, microservices, background services, interactions with databases with these powerful high level tools. But there's a lot of the runtime abstraction that allows you to build scalable applications, but then it, then you end up not having a deep understanding of the hardware because of that abstraction. So something that I wanted to change that, try and learn uh, systems programming, and um, doing it through Zig so far has been fun, and in the initial stages. But if you're following along, I do encourage you guys to take a look at ziglings. Essentially, ziglings is a fun way to learn Zig, and it's presented as a list of exercises made by Chris Bosch, and there have been a couple of other open source contributors, I believe. But what Chris has done is he's created this list of questions, which is almost like fill in the blanks, where you have these um, programs. There's an explanation, but there's an issue in the program. But by reading the explanation, you will be able to solve that issue. So it's like fun little puzzles that you can solve, and over time they add up to you gaining a foundational understanding of Zig, its syntax, and the idiomatic way of doing systems programming in Zig. So yeah, it's been incredibly fun so far, and I'm learning this for the first time. I do not have a systems programming experience, so it's all the more fun to do these fun little exercises. Almost, um, depending on how you ask, they may or may not like this, but it's the lead code to learn Zig, but it's a lot more fun. Okay, let's dive into the IDE, and we'll take a look at the exercises. Okay, just to do a very quick recap, previously we looked at a simple Hello World program, and we looked at the Zig standard library where we were introduced to this idea of comp time, and then we looked at assigning constants and variables and how they behave. We also took a look at arrays, the concatenation operator, also some fun little operators with type conversion, which is the add as well as we looked at the add bitcast, which is again showed how we can convert a value from one type to the other. So a lot of fun stuff, a lot of a lot of interactions with the type system. Um, so along the same lines, now let's look at strings. Okay, let's get started. Now that we've learned about arrays, we can talk about strings. We've already seen Zig string literals. Okay, yes, we've seen these. We've seen hello world. Again, we have \n, which is escape sequence, which represents a new line. It just means that if we were to print it, hello world will show up and the cursor will move to the next line. Okay, and then we have Zig store strings as an array of bytes. Yep, very common just like any other programming language. We have um, characters and we have strings being an array of characters. One quick distinction though, I like their usage of bytes, and I already see it here. It's not um, actually, this is a distinction compared to other languages. Um, Strings are an array of bytes, which also means a character is a byte expressed as an unsigned integer of 8 bits. Again, shows how a Zig syntax uh, prefers specificity um, over any sort of abstraction. That's pretty cool. Um, and here it's saying it's almost the same as the array definition. Okay, so this and this is almost the same, and the caveat being we'll see what, okay, we'll see in a later exercise. Yep, okay, we'll develop that patient's bone and trust the process that whatever isn't spelled out here, we'll learn over time, and there's a reason for it. That makes sense. We'll operate for now under the assumption that um, this representation and this representations are the same, and we'll understand how what are the nuances down the line in a later exercise. But a good call out on the specificity of saying this is bytes. It's precise. It's bytes. It's not a character. Characters are also represented as 1 byte. So one character is 8 bits. Okay. Most languages, the conversion is also straightforward, but usually there is a data type called char or char or essentially char, but we don't have that in Zig. That's pretty cool. And another call out is the use of single quotes for characters and double quotes for strings. Yep, that's again common in C sharp. I've seen it in other languages, except in JavaScript and TypeScript, I believe is used interchangeably. But again, most other languages, say Java or C sharp, there is a clear difference between single quotes and double quotes. Let's dive into the code. We have the standard library here that we're importing, and we have the entry point of the public main function. And we have a constant. Okay, and we're assigning it to Stardust. Now that I have the Zig extension installed, the LSP is telling me that hey, this particular constant is of this type, which is asterisk const, and there's a bracket notation indicating the size, I believe, and there's 8:0, and it's of unsigned integer of 8 bits. Okay, that's interesting. So I do know from C the asterisk is a pointer. It represents a pointer. It's used to define pointers. I do not know if it means the same in Zig, but I believe this line here essentially is exposed by the LSP here. There's something happening here. We'll trust the process. We'll circle back to it in further exercises, but it's a good indication to see what's happening here. Let's move on to the next one, but that's fun to know. Okay, the first problem. Even before we tackle the problem, let's just read it. It looks like we have square brackets. We can use the square bracket notation to get the letter D. Makes sense, because from this assumption we're saying, hey, this string essentially can be represented by this array of bytes, which also means that we can now start indexing and getting the characters using the index. Let's see. Now we want the letter D. What will be the value? Say 0 based indexing, so 0, 1, 2, 3, and 4. So if I'm going to write 4 here, it'll give me the value. Before I do that, I want to make it a practice of running the program just so that I can understand the compiler errors better, errors and messages, and that's a huge portion of why we're even learning systems programming, because we want to team up with the compiler and get better at this, and not be strangers. Okay, pretty obvious. VS Code is already highlighting syntax errors are always caught first. We've seen this before in the other small exercises as well. Let's add in 4. Perfect. So this should now be D. I'm just going to add a comment for my reference. Let's go back. Let's go to the next one. Problem 2, use the array concatenation operator to make Major Tom. I wonder if this is a call out to this David Bowie song. I think it's called Life on Mars, and it's a reference to Major Tom. I wonder if it's a call out. I'm not sure, but that's pretty cool. Yep, pretty straightforward. We can use the array concatenation operator. Again, we can do that because we're operating under this assumption for now. And the fact that it's working means the assumption is correct to an extent. We'll learn the caveat in time. Let's see. Let's go and run the code. That's all our problems. Then we have our output. We have D equals, and we have 2 placeholders where this anonymous collection will be replaced on a first come first serve basis. And we know we have UNS, which is probably the type of data we're passing in, or the format in which we want to display. S, we can say, stands for string. And U stands, let's see, we'll notice UNS, placeholders, we have the print function, and U represents a UTF character. Okay, that makes sense. D is nothing but an 8-bit integer, an unsigned 8-bit integer, which means it can be represented, which is essentially some number which, when the number is put into this UTF table, yields a character. Yep. Okay, yeah, it's saying if we wouldn't do this, it would throw an error. For example, let me replace the U. I believe it'll work. Again, the unsigned integer to character conversion is pretty straightforward in this case. However, if we remove this, it will error, like the instruction says. Let's see what the error is though. Perfect. It is very straightforward. It's saying we are unable to format the slice without a format specifier. Okay, this is a very good error. It's clearly letting us know exactly what the problem is. It's saying, hey, you're trying to display, print something, but we cannot print it because there is no format in which the value you're passing, which is of any type, I believe. Yeah, you see this is of any type. Now we don't know how to put it in this format. You need to specify that. So if we go back and add S, that'll instruct the compiler, hey buddy, this is exactly what we need you to do. I'm sure that there will be an underlying implementation to print strings in this exact format whenever the specifier S is presented. Okay. Now let's see here. Yep, this is 100 and it's not a character again because we're not specifying the format. It's displaying the decimal value. If we were to change it to UTF, it'll display the extract character. Perfect. Now it also says here, while on the subject, C ASCII encoded character can be used in place of U. That does make sense. If we do C, it'll also print the letter D. Why does this work? Honestly, because UTF is a newer format which is um, essentially like a superset of ASCII. So the first 128 characters, say for D, the value was 100 in ASCII. In UTF, it remains D. I wonder if that was done for backwards compatibility, most likely, but essentially, 100 in ASCII format also stands for the lowercase d, and 100 in the UTF format also stands for the lowercase d, which is why we can use it interchangeably in this particular context because we know we're printing d beforehand. And we know it because we're applying a subscript or we're indexing on this string here. Um, and if anyone's curious, um, we can find UTF or ASCII to UTF table. Yep, or we see it here. Character 1 to 127, which is a total of 128 characters. These are exactly the same in ASCII as in UTF. Therefore, we can use the formats interchangeably. Okay, let's get back into the code. We have a good understanding of strings. Let's move on to the next exercise. Okay, I'll clear the outputs. Nice. Okay, this seems very straightforward. We're looking at multi-line strings. They begin with two backslashes, the opposite of comments. Um, Pretty straightforward. Nothing um, to think about here. See if you can make the program print some songs. Oh, let's do it. Two backslashes, two backslashes, two backslashes. And again, we have the format specifier for strings. Zig run 007. Yep, pretty straightforward. Ziggy played the guitar. Oh, and jamming good with Andrew Kelly, and the spider is from Mars. Okay. The fact that it's saying Mars here makes me confirms my suspicion, I guess, that Major Tom was from the David Bowie song. But yeah, this is fun. And Andrew Kelly, I believe, is the creator of Zig. In fact, I started this particular series where I learned Zig because I saw an interview of his with JetBrains, and I was absolutely amazed by how well he conveyed what Zig is all about and why precision and specificity in writing code that interacts with hardware and being precise is important. So yeah, a fun little tidbit there. But this makes sense. We have multi-line. The syntax, the grammar for multi-line strings in Zig. This is a common. There are similar equivalents in every language. Okay, let's go to the next one. Let's do a quick quiz. This should be interesting. Quiz time. Let's see if you can fix the whole program. You'll have to think about this one a bit. Okay, let the compiler tell you what's wrong. Perfect. This is sort of the mindset we're trying to get into, that I'm trying to get into as well. I'm not just go straight off the, because in web development, you run the program, you see the output, or you heavily utilize the debugger, put in breakpoints, and all of that is really fun. And at some point, we will start doing that as our programs get bigger. But right now, just simply using the terminal, seeing the output, while we're still comfortable in VS Code, helps us team with the compiler to learn the language. The more familiar we are with the compiler, the familiar we are with the systems, and naturally we'll be better at systems programming. That's a goal that I have for myself. Perfect. Um, okay, we have the standard library, we have the main function, we have our string here called letters. and this beautiful type here that we will learn in due time. Okay, now we have another interesting thing here. Um, um, so we have note usize is an unsigned integer type for sizes. Okay, the exact size of usize depends on the target CPU architecture. Okay, okay. We have used U8 here, but usize is the idiomatic type to use for array indexes. Okay, I think I know what's happening here, and I do have some sort of an understanding of why we're using usize. There's a problem on this line, but usize isn't it. So here's what I'm thinking. Let me just create something. So previously we were using U8, but now we're using usize. And they seem to say that this is the idiomatic way in Zig. Um, but I believe this is where we're touching into the systems programming mindset in the language. Sort of makes sense. So, say an unsigned integer can represent, I think, numbers from up to 128, is it? Um, 2 to the power 8. I believe it's 128. Let's look at one of these previous ones. My bad. Uh, that's right. My bad. An unsigned integer can represent anything from 0 to 255. That is exactly correct. Um, um, Again, that makes a lot of sense because we're not we don't have to worry about negative numbers. So 255 is the max that we can represent because the first one is again taken by 0, I believe. So anywhere from 0 to 255 can be represented. Now usize, I believe, depends on the CPU architecture. It could be so each value could either be 32 bits, 64 bits, so on and so forth, I believe. This makes sense because when we're talking about an array and we're indexing the array, we will know the number of elements beforehand, but I'm sure there's a reason to do it this way. And yes, an unsized, an unsigned again, um, makes a lot of sense. Usize or unsigned size, that makes a lot of sense because why would you have a negative index in an array if we're going to be following zero-based indexing? So I wonder if it has something like this. Um, yeah, that makes sense. If it's the idiomatic way, let's start getting into the habit of using it. Okay, it says that there is a problem on this line, but um, unsigned size isn't it. Okay, we see a problem. What do we do first? We run the program. Okay, we see that there is an error, and the error is in line number 36. Syntax errors. I believe this line is saying that there's a logical error. And while scrolling down, I think I almost caught it right here. And I know what the error is. But let's just comment out the syntax errors for now, and we'll circle back to it. Because I don't want to put in some value here just to satisfy the compiler. We want to take the approach of solving the problem, and we're asked to do it from the top down. So let's do that. Okay, let me run it again. Yep, we see it very clearly. We see the error in line number 35. There is a problem in this line. The problem in this line is that we have assigned x to a constant. So there's a constant value, and we're logically breaking the rules that we ourselves set by saying this will never be reassigned, and we're trying to reassign it. Although the error stems from here, the truth is our initial declaration is wrong. Let's change this to a variable, and I believe we would have solved the error. Perfect. Interesting. Now we can see that we've displayed lang, which was just assigned here, and there are two interesting characters here. Let's trust the process, and I'll trust the process. Let's see what's happening. Note, when you want to declare a memory, an array in this case, without putting anything in it, you can set it to undefined. There is no problem on this line. Okay. Right off the bat, I do have somewhat of a twisted idea of undefined from JavaScript. At least me personally, I try to stay away from undefined as much as possible, but from reading this line, undefined here is a little bit different from a JS. Undefined very clearly here represents that, hey, lang array is just defined, it is not initialized. So there's nothing here. It's not that it's initialized to empty, it's initialized to nothing. Okay, that is good. Again, my apprehension for this keyword stems from JavaScript, but this makes sense. Where it also makes sense in JavaScript as well. Not that is wrong. I understand JavaScript did it for backwards compatibility, and that's a language that's been very successful for years and years. So due respect there, but from a Zig's perspective, I believe I get what undefined means here. Cool. Right off the bat, I think I know exactly why we have these this fancy characters being displayed on the console. I'm sure it has something to do with these two values not having valid, these two I don't know, memory locations or slots in the array not having valid values. But let's keep going. Trust the process. The following line attempts to put zig into the lang array we just created by indexing the array. Okay, so we have this letters, and we're trying to extract zig. Yep, we're using letters, variable x. The first letter is already assigned. We've initialized it to 1, x is 1. So lang goes 0, which we defined here. Again, it's precise syntax. An array of unsigned integers. Each character is 8-bit. Okay, that's it's fun. It's just it's really not complicated. It's just a fun way to put things in. Because usually we'll just call it a string and move on in a high-level language, or say a character array in some other languages. But yeah, it's very nice. There's no string as a class. There's no character array string as a class. What's a string? Nothing more than an array of bytes. I do have a sense of appreciation for it, which is nice. So we have lang of 0, and we're assigning it to letters of 1, which is 0 and 1. And now we want to get I here. Let me comment this, and we'll say lang of the next slot, which is 1, is letters of what's I, 2 and 3. Index should be 3. It's already there, it's 3. And the next one would be G, which is 5. So 6 is the length, so I'll go and say the last one is 5. Let me uncomment this, and we'll assign x here, and all we're doing now is printing the value. So it should print program in Zig. Let me clear this, let me run it. Perfect. We got it working. We were able to figure out this fun little exercise. Again, these are very basic, fundamental exercises, but I still think um, Chris Bosch has done a great job of building these fun little exercises, which are really, really not hard, but it still makes you think, which is amazing. And I like that it's meant to be run locally. It's fun to play around, get the compiler outputs, see the errors, understand it, and then fix it. Um, so let's see. I think we spent about 30 minutes to the mark. Um, and I know these were like shorter exercises, but we're taking our time, we're understanding it, and that's the whole point. We're not trying to build a big massive project right away. We're just trying to learn Zig, learn systems programming through Zig. So we want to take our time. And I think my main takeaways, since we had a little quiz here, and it seems like he's made a quiz at regular intervals. Um, yeah. So I think let me reflect back on the previous um, exercises. Again, starting off, the hello world was a explanation of how we add um, um, the import declared, and this was interesting. We have a constant placeholder here. Um, we have a constant placeholder here, and um, this is again something new that's very Zig, a Zig way of doing things. I've not done something exactly like this, but we do have aliasing in other languages. Um, but a fun little syntax. And we have a public main function. This is again quite common in Java. You have public static void main. In C sharp also you have public static void main. And sometimes in the modern C sharp you can ignore it, but once if you see the output of the compiler, you will see that a main function comes and wraps the top level statement as well. So this is in line with most languages, void being the return type straight up, because we're not returning anything here. That was fun. And we also gained an understanding, a beautiful understanding of comp time. I'll give a shout out to the Stack Overflow answer here. This was a very beautiful read where you went through what is comp time, how it's used, and how this idea in Zig that type itself is a compile time construct. It's not something it's not a runtime thing. That was an interesting thing to read, and takes a little bit of time to wrap your head around. And I still haven't fully understood the concept, and I will, as we um, keep trying examples, we'll get a grasp of it. But yeah, it was a very, very fun concept to learn. Also, we learnt about constants and variable. That's the rite of passage for every programmer, software engineer. After the hello world, we understood how constants work, and how variables work. We looked into arrays. We looked at the different operators where we can concatenate the arrays. That was a lot of fun. We also understood type coercion as a concept, which again, the example, it was such a simple, straightforward way to demonstrate so many things. Type coercion, repetitions using the splat operator, um, as well as bitcast, wherein we convert from one type to the other, and how in Zig, whatever type you're assigning it to, um, a type conversion can understand that and makes that conversion. So yeah, and when you're not assigning it, you can use this type coercion operator. This was a very, very fun, very simple, straightforward, but fun exercise. Props to Chris Bosch again. Very appreciative of the work he's put into it. And now we learned about strings, and again, something that has immediately struck me was how this is defined as an array of um, bytes, and a character is nothing but 1 byte or 8 bits represented as an unsigned integer. Almost all languages that I've used represent them either characters or character arrays, or in C sharp and Java, for example. Generally, you tend to use the higher level abstraction over it, which is the string class, not a primitive type. Yeah, primitive type, but it's still a class, system defined higher level type called string. This, I believe, was the most straightforward way I've seen strings. Um, it's kind of fun, just fun to appreciate it. I know it's not a big concept, and we have a long way to go. At least I have a long way to go before I can call myself as even remotely competent in string. It's probably going to take me years, but it's still very fun, and you can sort of appreciate um, the people who put their thought into this. Again, I do want to call out uh, this article. It's a very fun read. I don't know if I had shared my screen when I clicked on the link, but this was the article from about comp times. Yeah, it is very clear explanations, very straightforward, easy to understand the concept. Also want to call out ziglings. If Zig is something even you're remotely interested in, take a look at this. While they also have documentation here, and I did briefly look into it at one point. I honestly immediately heard about ziglings and just jumped onto this because what better way to learn something than to do exercises? That's all from me. If you found this interesting, do follow along, and I encourage you to clone the repository or fork it. Honestly, I cloned it because I thought I'll just host it on GitHub. But if you want to fork it on Codebug, go ahead and do that. That's probably better. But yeah, it's a fun language, and I'm having a great time learning it. I'm in the very early stages, but um, these small steps will help us progress towards understanding it better and better. And hopefully, towards the end of it, months down the line, we can start writing these system programs, collaborate with other people who are writing them, and be a and contribute well into the Zig community. That's all I had for today. See you all in another video.